Hi everyone! The SIFT project is pretty much complete at this point. There's just a couple of things that I want to do to really finish this project off, and I guess you could say put the icing on the cake. Now, one of those things is painting up this project box, which means that I have to take everything out of this box again, but I'd planned on that because this is the prototype. This is the very first one, so the first one is always the most work, right? And I'm going to also design up some artwork for this box that I'm going to share with you. So if you guys want to make an exact copy of this little project here, you'll be able to do so. I have a drill guide included for the top side and everything, and we'll go through that here in just a little bit. Now, in order to do the artwork for a box like this, there is a little bit of a process involved. The process really isn't all that hard, but if you do the process right, you end up with a very professional looking device, just like the Super Probe box and things like that. So I'll share that entire process with you here very shortly in the future, and you can use this process for many of your own projects as well. It doesn't have to just be stuff that's done here. Really, the magic is in the paint, the labels, and things like that. Again, I'll share that with you here in a future video coming very shortly. So for now, I feel comfortable sharing this with you because this works so well. This, I had planned on actually having the box painted and the artwork done and then doing a video very shortly thereafter, but this thing has been all-consuming. The amount of time that I've put into this thing just to make this thing to the point where I feel comfortable sharing this with you is just been in an incredible amount of time. And let me tell you, this is going to be released pretty much the same day that I'm making this video here. That's how much time this is. So since the last video to now, all time consuming. Again, lots of critiquing the project. I want to make sure that this thing works as good as it can without acting up. Basically what I'm doing is, I guess you could call it just critiquing the gain, pushing it as far as I can to make it go right, make this thing as absolutely as sensitive as I can without the thing acting up crazy. And I think I've got it to that point, and I'll share those secrets with you here when I explain the circuitry. So what I'm going to do is I'm going to zoom in the camera here, and we'll take a closer look at the underside of this. We'll take a look at the circuit board and how I've put things in here. We'll take a look at the component map, the drill guide, and we'll take a look at the actual layouts and what you will do to make the printed circuit board inside this box. Here's the newest circuit board design for the all-in-one SIFT device. On the top is the display section, in the middle is the amplifier section, and on the bottom is the newly added switching section. You'll notice from this trace right here that connects to the bottom of these three tantalums, everything above that trace is pretty much the same as on this board right here, this board that was in the previous video. Now this board was designed for those of you that have already built the switching device that can be used with an oscilloscope, this switching device right here. So if you already have one of these made, you can build just this board here and you'll have a display and amplifier section for that. So this would replace your oscilloscope. So this unit here replaces this and your oscilloscope all in one unit. So the switching section and the amplifier, display, everything all in one box. And this thing works very, very nice. I'm very pleased with the results. A lot of that has to do with this little section right here and playing with these capacitor values to squeeze as much gain out of this as I could. And it has a lot of gain. It's on the verge of oscillation. So in fact, it will flicker a little bit if there's no capacitor in there and the gain's turned right up, but that's absolutely fine because it settles down the minute you put a capacitor into the clips. Lots and lots of gain, works very well. I'll give you some demonstrations of that here in just a moment. So I tried my hardest to keep everything the same as in the other projects. The only difference is I've extended the circuit board. So the mounting is all the same as on this board here and in some previous projects. Everything with the display is the same. So this is even the same as the capacitor leakage tester. All the mounting is all the same and everything. It's just some of the other holes that have been moved around. So this device here will have its own drill guide. That will be included in the attachments below, and that drill guide will allow you to mount the two toggle switches and the VR in the right spot. It'll also allow you to get the grommets centered on the top side, right above here where the two coaxes solder into the board, and right down here we have two LEDs which fit comfortably into the top side of the box as well. Now, I've fooled around with a bunch of different standoffs to get this to stand as high in the box as I could, and as you can see, it's standing pretty high in this very deep box here. The reason I did that is because, just get these two wires out of the way here. The reason I did that is because I want to have access to these two diodes here. If for ever any reason I was to accidentally put a charged capacitor in here or something like that, the first thing that's going to attack is these two protection diodes here. These are very easy to get at. If you have a hot air tool, just basically put your tweezers on, heat it up, pull them off, and put another one on, just that quick. And it's even quicker if you have two soldering irons. Put a soldering iron on this side, one on this side, pick the component off in like a second, and you're ready to go. A little bit of solder wick to clean the pads off, and put a new component on there. So I wanted to have the component side up. Now, this is a double-sided circuit board, so you have the option of mounting this the other way as well. So the only reason I could see that you would want to mount this the other way is if you wanted the LEDs to go in the opposite direction. So if you wanted the, basically the level meter to move in the opposite direction, that's the only reason you would do that. I think having the component side up is probably the better idea. If anything ever does go wrong, everything's easily serviceable. There's really nothing on the other side except this very large capacitor that's folded over on the other side, and it attaches to this point here and to this point here, points that you do not see on this board right here. So in order to do this method, to do a double-sided circuit board, you do the packet method, and I'll have both the top and bottom toner transfer method pieces of paper, the layout I should be calling it, in the attachments below. So I don't have a double-sided circuit board tutorial on Patreon here, but I do have one on YouTube from quite a while ago, and it'll show you the packet method. I will do another one here solely for Patreon, kind of a more streamlined video, and I'll show you how to do the packet method if you're into doing that. Now here's the thing. This area needs a ground plane layer no matter how you look at it. So how I explained about using the tape in the previous video, you can do that with this as well. So in this version here, I had a little ground via down here. In the newest design, I've moved this up into this area. So if you just want to use tape to act as the double side, so basically you can keep the copper on the other side, you can do that very easily. And the places where you need to, basically have wires that don't touch the ground plane layer on the other side, you can take a larger drill bit and just run a larger drill bit around a few times just to basically take the copper off and auger a larger hole on the other side, and you can do all your soldering on this side. So any way you look at it, I tried to make this as easy and as versatile as possible if you really don't want to do the double-sided method. I strongly suggest that you do try though, because there's a lot of advantages to making double-sided circuit boards. So you don't have to have so many jumpers and all of these little vias right here. You can see a via here, there's a via here, there's a via here, and there are little vias all over the place, and that goes to the ground plane layer on the other side. Now, when you're designing a double-sided circuit board like this, there are no plated through holes, and it's a very simple fix. All you do is you get a little piece of wire, put it through, and just solder it on both sides, and you're done. You have a double-sided circuit board. This would be classified as an extremely easy double-sided circuit board. Down the road, we'll get into some more complex designs on double-sided circuit boards and how to basically put certain components in certain areas so that they don't listen to the other side of the circuit board with only a two-layer board. We'll also look at putting vacuum tubes on circuit boards and things like that as well. So there's a lot of very interesting things coming here in the very near future. So again, everything from this point up is pretty much the same as this board right here. You can see that all I've really done is I've taken the writing off here and I've put the components from this area, you can see right into here. I added this extension onto the board down at the bottom here that is very rigid, and there's absolutely no problems with having an overhang, especially on a piece of FR4 board that's so thick. Now you can get much thinner circuit board material that will flex, but this stuff here is so rigid that overhang is extremely sturdy. So what I'm going to do now is I'll take these nuts off the top here and I'll show you the standoffs and what the other side of the circuit board looks like and how I've mounted everything. It really is quite a basic design on the other side. Once we've done that, we'll take a look at the component layout and I'll show you the component map. I designed a really nice component map that'll make population on this board very nice. I have the nuts and washers removed from the standoffs on this side of the circuit board, so I can just give this a little bit of a tug. There's a bit of resistance because the coax cables that run through the grommet on the top are very tight. I like that nice and tight on the top here. That way, if you're moving the coax around, it really doesn't put a lot of stress on these joints down here. I'll get this into focus. So you can see over here, the center conductor runs right over to this pad here, and the shield of the coax is soldered right to the ground plane. It's the same on this side here. So you can see the center conductor is there, and then the shield of the coax just runs down over here to the ground plane layer. So you can see the advantage of having a double-sided circuit board. The double-sided circuit board puts a pad on this side and a pad on the other side, and then when you run the center conductor through those two pads, you get, a nice solder connection here, and on the other side it's nice and tough. You'll notice that there's also pads on this side here as well for the LEDs. So when you're putting the LEDs in, of course you would drop all the LEDs into the board and they would fall in, and then you would put the board into the project box like this, and then put the circuit board in, and then you can pretty much shake the circuit board and the LEDs will just fall right down into their respective holes. And then once you make sure that all the LEDs are perfectly set in their holes, you just solder this side of the circuit board. So what I usually do is solder one side only. I don't solder both sides, I solder one side, and then I check to make sure that all the LEDs are sitting perfect in the holes. If they're not, you can just desolder or heat up one side and maybe give it a bit of a wiggle if it's not all the way down. Once you know that all the LEDs are even, they're all even in the box, then you can solder the other side, the other row, and then you can solder this side as well, which makes them very, very tough. So nice strong connection here. You can see that this capacitor that's mounted on the top of the board is mounted on the bottom side here in this little area. So that's the reason I put these two little spots here. Let's get this out of the way. This little spot here and this little spot here. So if you want to test this outside of the box, of course you're going to need this in here because this here brings this, which is the negative connection here, onto the other side of the board. When this is tightened into the project box, this will make contact to the actual standoffs in the box right here, if you're using metal standoffs. The capacitor, as mentioned earlier, is soldered to this one side right here. So the actual leg of the capacitor is acting as the via. It's running right through here. And the negative just runs over and onto the ground plane layer. I'll see if I can get a better shot of that. And there you can see right there, just runs down and over and is bent onto the ground plane layer. These other little solder dots that you see are just vias running through. So vias from here and little vias all over the place. That just connects to this other side. So this is used as a common and a ground on this side. You can see the wires that run over here to both of the switches and the VR. So this is a 100 kVR, and I'll explain that here on the component map in just a little bit. This is the on-off switch right here with a 120 ohm resistor from one side of the power switch to the ground. Why do you think I added that 120 ohm resistor right there? Yeah, that'll give you something to think about until we take a look at the component map. So we have the positive running from the battery here, and then we have this positive goes to the circuit board, and then we have a 120 ohm resistor to ground. Interesting. So now, over here is the intensifier and just the gain switch over here. So I didn't need to use a switch with basically two rows on it like this. I just had two matching switches, so I put both of them in. So they just looked the same and they worked very well, and they had the two same bat handles on them, so I just wanted to make them match, so I just used this. I could have gotten away with a single row, basically a single pole double throw switch. So let's see, what else can I tell you about this? That's pretty much it. That's on this side. Everything is just wired to this side and soldered on this side, and then they're used as vias on this side. Runs through. You don't need to do that. You can run the wires onto this side of the board and solder them in on this side as well. And again, as I mentioned, if you don't want to use the double-sided circuit board method, if you were to just put tape across here, of course you wouldn't have this area with the pad in here, but you still have a pad on this side of the circuit board, right? You still have a pad over here. So if you take a drill bit and then auger away at the ground plane layer so that, you know, the center conductor doesn't touch the ground plane layer, you can use a single-sided board if you, or you know, basically the single-sided pad on this side here. This does need the ground plane layer, so either way, you can try the double-sided circuit board. You get the bonus of having these pads on the bottom side. Or you can just use the packing tape method that I talked about in the previous video, and that will get you by. Now you can see how I have this one little via down here. This little via went up to this area. In the newer layout, I corrected that so that this will run over here. So if you are going to use the packing tape method, it makes it a whole lot simpler. You don't need to run a bridge wire over or anything like that. And I'll show you that here on the layout shortly. And that is the other side of the circuit board. So I'll get this out of the way. I'll get it put back together again, and we'll take a look at the layouts. The first attachment that we're going to take a look at is the drill guide. So the drill guide really makes things nice to align on the top side of the box. So what you're going to do is grab your metal project box. It can't be plastic for this project because this thing is so incredibly sensitive. It needs to be completely shielded in a metal box, from metal or aluminum or something like that. So you're going to take your box like this. You're going to cut this out. So you're going to want to cut this just a little beyond the line because you can see this is centered right on the actual lines here. So cut this just a little bit beyond the lines. This here will allow you to center this on the top side of the box. So you're going to want to draw a line straight down the center, like what I've done on mine here. See that line that's been erased already? And then what you're going to do is align this line up with the center. So you can move this around. You want the row of LEDs close to the top. And of course, we're going to have two standoffs here, so you don't want to get too incredibly close, but you know, you're going to want to have this a little ways from the top, like what you see on mine here. And that way, there'll be some room on the bottom portion of the box for you to put your battery. So once you have this all cut out and this all centered, so you've aligned this up to the line on the box, move this to, you know, the position where it would sit, you're going to tape it down. And you're going to take a center punch, and you're going to take your center punch and put it right into the center of each one of these little holes here and center punch it. So, of course, this is on top of the box, like so. And you'll be center punching all of these, and you'll get a nice straight line, just like this for the LEDs. So one of the tricks to keeping that line straight is once you've center punched all of these, you want to take a really small drill bit, and you want to pre-drill each one of these holes. If your center punch hasn't left, you know, enough of a little divot there, you can put your center punch back into that and hit it one more time. I prefer a spring-loaded center punch myself. And you hit it one more time just to make it a little bit deeper so that it'll guide the drill bit directly into the center. So what I do with my drill press is I shut my drill press off, and then I bring it down and rest the drill bit right in the center of the little punch hole, you know, where it's punched the little divot. And then what I do is with some very light pressure, I just hold the drill bit down onto here. I turn the drill press on and then bring the drill bit through, bring it back up, shut the drill press off, and move to the next hole and repeat again. So you're turning your drill press on and off quite a few times to do this. But the result is a really nice clean line. So if you have your drill bit running or your drill press running and you bring it down and you're not perfectly careful, if you even just you move that little center punch divot off to the side a bit, you're going to have a crooked line. So this way it allows you to center everything and make sure that the job just looks good. And you want to do that for all of these here. So this is for the VR, this is for the switch, this is for the switch. So you can drill these holes to the sizes that, you know, to the VR and the switches that you have. And of course you'll drill these to the size of your LEDs. And these here will be the mounts. So there's a mount here, mount here, mount here, and a mount here, like you see on the box, right here, 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 and here. And we have the two LEDs down here, which are these two, and these are the true rubber grommets right here. These 2 1/4-inch rubber grommets with some nice little small holes that hold the coax nice and snug. And that's the drill guide. So choose your side and you can put that on the top of the box and get a really nice clean result. So that's the drill guide. Next attachment will be, this is the top side of the circuit board. You can see it's already mirrored for you, so you just print this off exactly the way you see it, and then with your circuit board, this would be, say this is the copper on your circuit board. Since this is the toner transfer method, this is going to be down like this, and as you can see, this is the right way. So the top side is mirrored, the bottom side is not mirrored, and that's how it works when you're doing the toner transfer method. So this would be on the bottom side of the circuit board, so you're looking down through this, through the circuit board and to the bottom side, so this doesn't need to be mirrored. Another way to check that is this dot should line up with that large dot over there. So you're going to use the sandwich method. You're going to want to print this out in this format right here, which is landscape. You want to print both of these out. You're going to cut 2 strips off of here, and the top layer will be a little bit shorter this way, and you'll leave the bottom one long. And once you've got these aligned up, you'll take your tape and tape the top layer to the bottom layer like so. Stick your circuit board, once it's been completely cleaned and dedusted, in between here, and then that will go through your laminator, or you can iron it if you're very careful, one or the other. Laminator is definitely the preferred method for this. So that's a packet method. Again, I have a video on YouTube showing this. I will make a future video showing how to do this here in a more streamlined method. So these are one attachment. So this one's on the top and this one's on the bottom, like so. Print in landscape, definitely. Don't forget to do that. I also want to make sure that your printer is scaled correctly when you're doing that as well. So you want to check things out. If you're going to print that off, take the LM3914V and drop it onto that other layout, and it should sit perfectly on top of this, and all the pins should line up right. So drop it on here to make sure that everything is scaled. Another really good way to make sure things are scaled is just take that little 555 and drop it on here, and that should line up with the pads perfectly. And if you find that the scaling is off, you're going to want to adjust that. This is scaled correctly, so if there's any scaling issues, it's definitely something that's been adjusted on your end. So this is printed on a piece of legal paper, so you're going to want to keep that in mind when you print this out. This way I could fit everything on here, make it a little bit bigger. So this is the component map for the entire unit here. So the component or parts list for the bottom portion is all right here. So this is here. In the previous video for this was a component map, and then there was a separate parts list. So in order to populate the upper portion here above the line, just print off the parts list from the previous video, and that'll give you all the parts for here. And then down here, we have a parts list here. There's one addendum that I've made to the upper half, is I've changed this. There's a capacitor on the upper portion here, this 0.01 microfarad capacitor. This was 0.039 previously. It'll work with 0.039. You'll find that you just get a bit more sensitivity, and it's more, it's 0.039 really is attacking more of the noise. Since this isn't such a nice shielded box, I could down that a little bit and get away with a 0.01. So that's the only thing that's really been changed. Again, not really big deal. It'll even function pretty well without that capacitor. I've removed the pads here beside the 1N5711 because we're not going to be using that resistor there. And that's pretty much all that's changed up here aside from drilling these other vias. Everything else is pretty much the same. And this is all the new stuff on the bottom here. So I've marked pin 1 for these little ICs right here. This one here, pin 1 is very easy to see because it has an oval pad. This is the ZSR 500, it just fits only one way. Put that on there. And everything is all marked down here. It's really self-explanatory. Cathode, anode for the LEDs here. V stands for via. So this is the signal in pad, and then this is ground. You can see the bottom portion of the diodes tied to this via, and that has to go through to the other side of the board and get soldered there. So all the vias get soldered to the other side of the board. Same over here. So this is the ground or the common for the coax. And you can see here a little jumper. So this is the 0 ohm jumpers, 1206 times 2. So they're pretty large pieces. They usually say 000 on them. So little jumpers right there. See if I can get one into focus here for you. There it is right there. It says 000 on the top. Little 0 ohm jumper. So that's the piece right there. All these are just little vias. And the only thing that would be changed on the schematic is I've added a 4.7 microfarad capacitor. That is shown on that schematic. It's off to that one side. And I put a 50 ohm resistor ahead of it. So as the IC, the 555 timer, pin 3 runs directly into this 50 ohm resistor, and then it runs out to the LEDs and this. That's the only thing that's changed on the schematic. Now, because of the length of time that this took to put together, just this alone took a lot of time just to label this and get all the parts and everything. And then, of course, this thing, just incredible amounts of time. Zero spare time for Paul since the last video, I can tell you that much. So this thing here, there wasn't enough time to actually draw a nice clean schematic of this. I will do that very quickly, and that will also be added as an attachment under this video once I have this whole schematic drawn out. So I'll draw it as one piece here. So over here, you can see, just like on the other schematic, this is all shown on the other schematic. I just redrew this here. So this is a 100k ohm linear taper. You want to make sure that you're using a linear taper style VR. Either that or you'll find that you'll get really close to the end before you get all the gain in. So a linear taper, it is a nice linear path all the way across. That's all that means. So usually they'll say B100K. B is usually linear taper. All right, so B100K. So that's what you'd see on your VR. This is the capacitor that's mounted to the other side of the board here, this 10,000 microfarad capacitor, and the positive lead runs through this little via right here. The negative side just solders to the ground plane layer on the back side. Here's the switch with that 120 ohm resistor over here. So you can see the 9-volt battery, right from the 9-volt battery runs into this little portion of the switch on the back here. The center of the switch runs up to the positive. And then on this portion of the switch, we have a 120 ohm resistor to ground. So when you click the switch on, all right, so when the toggle goes up, it connects the two bottom ones, right? So when the toggle goes up, if you have 3 contacts on the bottom of a switch, when you click the switch up, it goes down like that. And then when you click the switch down, it contacts these two. That's kind of how it works. There's a pivot up here, so it makes connection between these when the toggle's up. It makes connection with these when the toggle's down. So when it's in the up position, the unit is on. So it connects the 9 volts to the center, and we have power to our board. When we click the switch off, it now connects the board only through this 120 ohm resistor to ground. Why is that there? Well, to drain off this capacitor, because if you don't have that 120 ohm resistor there, this thing will keep going for about 10 seconds. And that can be awfully confusing when you click your switch off, especially if you put it off to the side and you see the thing still flashing back and forth, right? So to give you an idea of how quickly that drains off that cap, turn the unit on here, and I'll just let it start flickering here back and forth, switching. So now when I shut this off, see how quickly that goes off? That would still be going back and forth for quite a long time. So that 10,000 microfarad capacitor holds, quite a charge. So this just quickly drains that off. Now you want to make sure that the 9 volts is at this end and not in the center, because if you put the 9 volts in the center and this off to this side here, you're going to cook that resistor and drain your battery really fast. All right, so this is a 0.5 watt metal film resistor, and if you click the unit off, the thing doesn't even get warm. It just drains it off really fast. If you were to hook that across a 9-volt battery for a long period of time, of course it's going to get warm, right? It's going to also kill off that 9-volt battery. So make sure that the 9 volts goes into here and the center runs up to here. So very important there. Let's see, what else can I tell you here? I think that's pretty much it. For above the line parts list and further details, see the previous video for attachments. I already mentioned that. This is the line here. Again, the V's are for vias, LEDs, anode, cathode, and that's all the way across here. So you can choose your particular LEDs that you want. And that's pretty much self-explanatory. All the 5089s and everything are all listed in the previous video. So that's pretty much it. So all of these attachments are going to be below this video, and I will add more attachments as I get time to draw up a nice clean schematic. And right now the other schematic will work just fine. There's basically only 2 components that have been moved around on the other schematic, and for the top as well. So everything is fine. So for that, it's just basically cleaning it up and making things look nice. Just labeling this took an incredible amount of time in itself. And getting all the parts and everything all on here. Now keep in mind with these switches, again, when the toggle is up, if you have contacts like this on the bottom of the switch, this is two switches in one. So one bat handle moves two isolated switches back and forth. So when you move the bat handle up, it contacts the two bottom ones. So if it contacts the two bottom ones, you can see Y is intensify. So when the bat handle's up, it's on intensify. And X is gain. So when the toggle is down, it's contacting this one to this one and this one to this one here. So X is the gain position. So it gets kind of confusing because X is on the top and, intensifies with the toggle up, right? So you have to keep in mind when you're looking at the back side of the switch, toggle down, connections on the top side. Toggle on the top side, connections on the bottom side, right? So again, toggle up, two bottom ones connected, toggle down, two upper ones connected. That's the way that these things work. I've come across some really bizarre ones in the past. There are larger toggles, and they've actually corrected that inside. So when you click it down, it actually goes down. When you click it up, it goes up. And those are very bizarre toggles. I'd say 99% of the toggle switches out there are not like that. So they're, up is down and down is up kind of thing, right? And I think that is about it for all of the attachments. Let's check out the performance of the new SIFT device. It's really easy to set up. Just remember 12 o'clock. VR to 12 o'clock, toggle up, and we're ready to start testing. So this adjusts our gain. So if we need a little bit more gain to get an all or nothing display, we can adjust that. This is the on and off switch, and this is intensify and gain. So right now this is pointed up to the intensify position, which is nice for the smaller value capacitors. I'll show you the difference between the intensify and the gain here in just a moment. So let's test this 0.1 microfarad capacitor. Put this in the clips here. And as you can see, very nice all or nothing display. Remember, the least amount of LEDs indicates the outside foil. So least amount of LEDs. So this would be the outside foil here. Lots of LEDs, least amount of LEDs. Remember, the green LED that's glowing is telling you that that alligator clip is attached to the chassis or ground. So the opposite LED to the one that's glowing is the signal lead. So signal, ground, and it's just electrically flipping this thing around, right? So, and as you can see, outside foil on that end. So, this is the outside foil here on this end, marked much earlier. See how this indicates it. And there it is, it's indicating it quite well. If you give it just a bit more gain, it's a higher value cap. So least amount of LEDs is this side, and that's the outside foil. So this thing is so sensitive that it'll even test very leaky, almost shorted old capacitors. Look at this, it's even blowing its own innards out. So let's test this one here. In order to test this cap, since it's so leaky, this is 0.5 microfarad. It should still test on the intensify position, but this is so bad that it's going to need to be on high gain. So I'll put this in here and give you an example. So I'll put it on high gain, give it lots of gain, and as you can see, it's indicating the outside foil. Least amount of LEDs is this one right here. So if I left this on intensify, you would see that we would get, somewhat of a confusing display. One LED is lit. Now, as you get to the higher value capacitors, it's more important to use the high gain position, so you can see the difference there. So outside foil, least amount of LEDs right there. So it'll even test horribly old leaky capacitors, ones that look like they're going to shoot the end out. This has obviously gotten really hot and let off some pressure at some time. So now you'll see how important it is for these. I'll put this in the intensify position again. So this is a 2 microfarad capacitor. Right, so it's a pretty high value capacitor. For a coupling cap, that's huge. Look at the size of the thing, right? So what I'm going to do now is turn the gain to the absolute maximum in the intensify position. I'll hold this and look at the display. Now that's going to be mighty confusing, right? So if we click it onto the high gain, we can very easily see the outside foil. This is the outside foil right here. And if that's not big enough, let's go to 4 microfarad. This is getting kind of crazy. 4 microfarad coupling capacitors. Decoupling capacitors. That's pretty big. And it's still indicating the outside foil. Now think about that. There's 4 microfarad coupling the hum from my body right to ground. So this is acting as a filter right now, and it's still seeing that through 4 microfarad. Incredibly sensitive. Working very well. So there you have it. I'm excited to get this thing painted, and I want to get the artwork on this box. This thing is going to look so incredibly good, and I know already that I've got another new favorite piece of test gear. I have so many favorites now. So that'll be the next thing I do, is I'm going to get this thing painted and get a bunch of artwork done and make this thing look very, very nice. And I'll share that process with you as well. So I hope you've enjoyed this little SIFT tester. We're still going to go through and check out the signal path. This video is getting pretty long at this point, so we're going to do that here down the road. I'll go through and I'll show you how to probe each stage with an oscilloscope, and I'll show you how each stage affects the gain. And what we'll do really is we'll just feed a signal into it, and because it's going to be switching back and forth, right? So I'll feed a signal into it right at where the capacitor goes into the amplifier section, and we'll go from stage to stage, and we'll take a look at the gain and how incredibly high that gain actually is. It's an extremely sensitive device. I think you'll be very surprised at what the gain is of this particular device. So that's coming in the future as well. So very, very soon, in fact. So if you've enjoyed this video, let me know by clicking the heart symbol below or leaving a comment below. And I'll see you guys very soon. So bye for now.